Hi there, my name is Amit Grover and I'm a senior database engineer with Amazon RDS for Oracle engineering team, and welcome to this presentation. Today we will talk about the plan and execute your database migration to Amazon RDS for Oracle and how you migrate a self-managed Oracle database to a managed database on Amazon Relational Database Service, Amazon RDS. We will work through the steps to migrate an existing Oracle database to Amazon RDS, what you should consider when making such a move, and the tasks involved for migration. We will talk about how to plan and execute the migration to the managed database service Amazon RDS, which can help you transform the business and user experiences with agility and speed of innovation. One of the many benefits of moving to a managed database offering. We will also look at the best practices to consider while migrating and after you have completed the migration to make the migration experience fast and secure. First, let's take a brief look at what is Amazon RDS and some of the benefits of moving to a managed database offering. For most companies, database management is undifferentiated heavy lifting. Your data is one of the most valuable assets your company owns. But the management of your database is not where you provide value. Provisioning, operating, scaling, and managing databases on premises is tedious, time consuming, and expensive. Customers want to spend time innovating and building new applications and not managing infrastructure. Amazon RDS automates time-consuming administration tasks such as hardware provisioning, database setup, patching, and backups. AWS continuously monitors your databases to keep your workloads up and running with self-healing storage and automated scaling so that you can focus on higher value application development. AWS engineers have managed databases for some of the highest volume workloads in the world. We have built reliable tooling for all aspects of database management to ensure that your database is operating at the highest level. Amazon RDS gives you the freedom to choose the database of your choice, including the most popular open source and commercial database engines, and Amazon's relational database built for the cloud, Amazon Aurora. RDS allows you to scale across a global footprint of data centers with high availability and disaster recovery, no matter the size of the database. Our database strategy is really simple, always working backwards from what our customers have asked us to do. Next, we will look at different methods of data migration to Amazon RDS. Going to types of data migration, we have a lot of customers who have successfully migrated databases of all sizes to RDS. Think of it how you would move from one city to another. There are a lot of things you need to consider. Is it a one-time migration and you move to the new city from one place to another? Or you are traveling for a short-term assignment? When you are moving to the new city, are you going to do multiple trips to move, or are you planning to move all your stuff in one go? Alternatively, you can decide to move stuff in batches based on what's needed first and then the rest. There are some interesting similarities on how you do the migration between an individual moving from one city to another, or migrating a database from on-prem to the cloud, or just setting up a residence, taking that example again, in multiple locations, and the things you have to consider while planning such a move. A one-time migration could be the first step you take in the longer project that eventually ends up doing migration, or it could be the one-step move all that is used to move the database to the cloud. So that's one type of migration. You copy your entire database and possibly the applications that connect to the database to AWS. The use cases could be that you want to migrate your production database to RDS, or you want to build a POC or a pilot. Alternatively, it could be the first step in the project, after which you will do incremental migrations to move the database to Amazon RDS for Oracle. Continuous migration is something that will be very helpful with migration of big databases, which will need a lot of downtime if moved full in one stage. So you start with doing the first one-time migration and then bring in the incremental changes through log shipping or transactional application. This approach allows you to keep your databases, which could be on EC2 or in your data center, in sync for migration or for disaster recovery. The approach can also be used to migrate the database to and from RDS for query offloading or for disaster recovery use cases. You can use logical replication tools like Amazon RDS, Golden Gate, or Shareplex for the approach. If you decide on using this approach for migrations, once the incremental changes have caught up, you can fail over the application from on-prem to RDS with minimal downtime. And possibly the last one would be a periodic migration, where you did the one-time initial migration, but that's not enough. That's just one snapshot of your data that you copied. But you now want to continue to bring in incremental changes. And those could be table partitions that you are moving for reporting and BI type activities on RDS. Or maybe because you have production on-prem and you want to create development and test databases on Amazon RDS for Oracle. What do you need to consider moving to Amazon RDS? After you have thought about the approach you want to take to migrate your data and database to Amazon RDS, looking at what you want to achieve with the migration. The next important part that comes up is data source and data types. Do you want to change the data? Or do you want to migrate the data as is? We continue to learn from our customers and move fast to deliver new capabilities to meet their needs. As a result of the maturity of our portfolio, we also have the most number of customers using one or more of our services for their transactional and analytical workloads. And it's not just data, it's the workloads too. The past 15 years have seen an incredible shift of application workloads from on-premises, data centers, or co-location facilities to cloud-based computing. By using services from AWS, companies have been able to innovate faster, serve customers better, and keep their IT spend lower by migrating to cloud-based computing. Allow your developers to deliver more value by focusing on the features that matter to your customers. As customers move to microservices architectures and build loosely coupled distributed components for their applications, having the right tool for the right job becomes increasingly important. We like to say AWS is for builders, and when it comes to databases and analytics, we provide the broadest and deepest set of cloud services available in the market today. For example, if you are storing blobs for media in your database, with the metadata in the row, you can efficiently scale the database and reduce CPU and I/O usage on the database by keeping a pointer for the binary data in the database and storing the blob itself in Amazon S3. With Amazon RDS for Oracle, you don't need to do the undifferentiated heavy lifting and worry about database management tasks such as server provisioning, patching, setup, configuration, backups, or recovery. Allow your developers to deliver more value by focusing on the features that matter to your customers. Thus, customers want to lift and shift their database and analytical workloads to the cloud. And customers are doing this at the record levels across many different areas. This has allowed us to deliver managed database offerings, which are purpose-built for use cases, which include offerings in relational and non-relational databases, and also to support data warehousing, analytical, and reporting use cases with managed offerings in the form of Redshift, EMR, and Elasticsearch. As this brings more questions to the table, are you trying to figure out if the migration project is feasible and possible, and the restrictions that you will face planning for the migration? The first one to consider and think about will be the number of databases. If you're moving a few or a few hundred of databases, the next would be the average size of that database. The reason for that is you might want to standardize and automate or script migration steps that make you choose one migration approach to make it a repetitive process and not have to figure out things by using different approaches at different databases. Then the next would be if the databases are big and you have a few of them to move. Network bandwidth might be a consideration that could slow you down. It could limit you to move one database at a time, or even with one, it might take a long time to move the data for the initial load. This would also mean that you might want to start looking at approaches that don't involve keeping the application down for that long. Alternatively, it could be that the application availability requirements don't work for doing a one-time migration, as the approach that you're thinking about using cannot finish the migration in the acceptable downtime for migration. A few other things to keep in mind that might be a blocker for you to migrate to Amazon RDS would be the max supported storage size, IOPS, and bandwidth. Amazon RDS today allows you to scale the storage to 64 terabyte IOPS, 256K, and bandwidth of 4000 Mbps. Or the other blocker to move would be that you have a third-party packaged application that requires access to the database host or use sysuser access to configure the application, which is not available with Amazon RDS for Oracle. Physical migration using techniques like transportable tablespace and RMN restore as mechanisms for physical ingestion are also not supported with RDS today. If the allowed limits for IOPS and storage size or the application dependency or migration mechanisms not supported are what you are using to migrate your database, then you should consider migrating the database to Amazon Elastic Compute Cloud, Amazon EC2. Amazon EC2 still gives you the benefits of provisioning servers, not needing to install and patch OS, and HVAC and capacity planning in your data center. But you will perform more database management activities as the benefits of a managed database offering that come with Amazon RDS for Oracle, like automated patching, automated backups, high availability, and managed disaster recovery, won't be available. You will need to plan for those. Okay, if the total migration time is more than the acceptable outage, the recommendation would be to choose continuous replication as the approach for data migration. But with all of the migration approaches for the databases and applications using them, there are constraints around availability and downtime. And how does the migration approach impact the current production instance while migrating the data? For example, you might want to extract the data in parallel from the source production database while the application is online to reduce the time of extracting and moving data. But that could increase the latency for queries that the customers are running on the source. This might warrant you to increase and decrease parallelism on the data extraction based on the application traffic patterns, slowing down the data extraction understandably. Also, does this mean you have to do multiple batch data transfers to bridge the gap between the on-prem and the Amazon RDS instance as a last step before you can start replicating changes to keep the RDS instance in sync for final migration? Depending on the answers you give to these questions, you should consider the mechanism for data migration and how would you go about actually executing the project. Migration options for small databases. Small being a very relative term here, why I focus on small word here. But the idea would be that you can migrate the data within the acceptable application downtime for the migration project and where the data resides and what form the data sits in. Taking a snap example of materialized views. If you have a database size of 20 GB, but that has 5 tables and a lot of indexes, it might be easier to migrate the data using materialized views. Set up incremental refreshes and then create the indexes on the target. Sync up the materialized views using fast refreshes and keeping up the data in sync before you do the final migration. Alternatively, if the database size was still 20 GB, but instead had 500 tables in the database, being able to create and sync 500 materialized views and making sure you keep all of them in sync and not miss any to keep up will be challenging. This would mean you take a look at possibly using export import or data pump export import as the mechanism. These are the most common options for migrating larger datasets to Amazon RDS for Oracle. Obviously, you can use the native Oracle utility data pump to migrate your database from on-prem or from EC2 or from a different cloud. Amazon also offers a managed logical replication and migration service called Amazon Database Migration Service (DMS). DMS also uses native CDC support, which means you can combine the DMS service with native tools like Datapump. And then for even larger databases, which are multi-terabytes in size, more than 10, maybe 20 terabytes, and if you want to migrate those, you can use our Snowball Edge devices to extract the initial data load on the Snowball Edge device, which can be shipped to your data center. Once the initial data dump file is loaded in the Snowball device, the device will be shipped back to AWS data center, and then the data or the dump file will be loaded to the Amazon RDS instance, from where it can be loaded, and then DMS can continue to ship the incremental changes and keep the RDS database in sync with the source database. And then you can also use third-party replication tools like Shareplace and Oracle Golden Gate. Now, looking at more considerations on migrating to Amazon RDS. As you're migrating to RDS, there would be some things that you might want to, irrespective of the data migration approach, what the database and data types are, or application downtime requirements are for the migration project. Once you have finalized the migration technique and tools you're going to use to complete the project. If the teams managing the on-prem database have not yet used Amazon RDS for Oracle, create a few test instances and get comfortable on various options and automations provided with the managed database offering to see how the day-to-day management activities for the DBS change. Look at the compute power and memory on the instance and see if you have enough compute power to run parallel threads for data load. You might also have to open up network ports and security groups to allow traffic or connections from machines outside your application servers that you might need to run data load. Those can be closed after the migration is done. Take a consistent snapshot before you begin the migration at each milestone, just in case something goes wrong and you need to roll back to a consistent known state from a prior snapshot. On the image, on the left-hand side, you have the source Oracle instance, could be the on-prem or could be on EC2. And on the right-hand side, you have the Amazon RDS for Oracle instance. You take the export dump file from source, load it to the Amazon RDS for Oracle instance, and import the data to complete the migration. If your source database is large, this is how the overall process would look like. You take the export dump file from the source, load it to the Amazon Snowball Edge device, ship the Snowball Edge device back to the Amazon data center, from where the dump file is loaded on the Amazon RDS for Oracle instance, and the data is imported to complete the migration. If you are using Amazon DMS service to migrate the data from on-prem to Amazon RDS, this is how the process would probably look like. And just to also emphasize, this is very similar to how the process would look like if you are using any other third-party logical replication tool like Oracle Golden Gate or Shareplace. On the left-hand side of the image, you have the source Oracle instance, could be on-prem or could be on EC2. And on the right-hand side, you have the Amazon RDS for Oracle instance. You will start the replication instance, connect the source to the target, and you will choose which tables and schemas to migrate. And the DMS will create the tables and load the data. It can then keep those changes in sync. In the last step, you can decide to switch your application from on-prem to RDS and complete the migration or continue the replication to keep the instance as a DR target. We will see how DMS does the data migration. The first step would be it will start loading the data and will perform a full data load table by table and does 8 tables at a time. You can see here that the load is table by table and it loads 8 tables at a time because it starts 8 processes at a time by default. Number of tables loaded in parallel is controlled by task settings. If you want to speed up the migration, you can change the migration task settings. The changes that are continuously replicated from the source to the target are read from the read log or archive log files on the source database. You can also see in this image that your application is still pointing to the source, and the initial data load is being done to the target and the source is generating new changes. After the initial load is done, DMS can replicate changes to the target database close to the real time. And once the source and target are in close proximity of being in sync, you can choose to point the application to the target instance. You can stop the application pointing to the source database, which could be pointing to an Oracle instance on-prem or on EC2, and then make sure that application instance successfully replicates all the changes from the source to the target Amazon RDS instance. Once all the changes have been pushed to the target Amazon RDS instance, you can choose to start your application back up again by pointing it to the target Amazon RDS instance. This allows you to perform a minimal downtime migration. So, as part of your migration, you will need to choose and pick an instance type for a database in Amazon RDS. Amazon RDS for Oracle allows you to scale compute up and down and storage up at a click of a button. One major advantage of agility of the managed database offering, Amazon RDS. You might or might not want to size your target instance for migration similar to your current production instance. One reason for that would be that you might want to pick a more capable box which has more compute power and more memory to be able to ingest and load data faster, in turn reducing the migration time. You can always scale down the instance later or size optimally for the application workload. Additionally, you should also consider loading the data to the target database without indexes and create the indexes after the data has been loaded. This helps you load the data faster. I have seen databases where the size of the indexes is more than half the size of the database. Also, maybe you do not want to create all the indexes you have on-prem to the Amazon RDS instance to maybe trim down some fat there. Best practices. In general, though, as you are migrating to RDS, there are a few best practices you want to go over before you migrate, and then there are a few that you want to keep in mind after you have done the migration. And these are applicable no matter which migration method you use. Reduce contention by disabling auditing, logging on the target instance. Disable backups, which is creating archive logs on the RDS Oracle instance and using IOPS and slowing you down. Another thing to do pre-migration would be to modify the RDS Oracle instance to run in single AZ. Typically, we would recommend that you run RDS instance in the multi-AZ configuration, which is the managed HA feature built into Amazon RDS for Oracle that does synchronous block level replication between two instances in different AWS availability zones. The synchronous replicated instance is going to slow down the bulk data load that is going to be done for the migration. So for the duration of the bulk data load, it is to single AZ and then back to multi-AZ after the data load is finishes. Same with indexes, which will slow down the load, create them on the target after the data load. Pick the right instance, type of the data load, and this might be different than what you might choose for running the RDS instance, but you can always scale the RDS instance up and down quickly with Amazon RDS for Oracle. Enable enhanced monitoring so you can see if the data migration is being throttled by insufficient memory, CPU, or the instance is swapping. So you can take remediation actions to finish the data load quickly. As part of migrating data to RDS, you should provision storage for size of the export dump file and also for that of the data in the database. Take an example. If you are moving a 200 GB database and the export dump file is 100 GB, if you create an instance with 200 GB storage, you might not be able to finish the data load. And before you move the application to the RDS instance to which you have loaded the data into, take a snapshot and restore the snapshot as a new database and test the performance with the data. Test and repeat the migration process multiple times to test and find out how you can optimize the migration process to make it faster. Also, not just the process, align resources who are focused on the migration project and create regular checkpoints to see if you are on track for not just the migration of one database, but also for the project as a whole, if it involves more than one database that you have to migrate. Now, the moment you are done with the migration project, you want to turn on your backups. You want to go back to multi-AC. At this time, you might want to configure your read replicas, because there probably was no point running read replicas during the major load or migration. Configure disaster recovery with cross-region automated backups or cross-region read replicas per your RTO and RPO requirements. Tighten down that security again. You might have opened up ports and holes in your security group for migration, and now you want to close them. You want to check that CloudWatch notifications are turned on at this point, so you are notified about database events like CPU or storage exceeding the threshold. And here are some of the specific resources that can help you with learning more about Amazon RDS for Oracle, where you can find detailed documentations, papers, and customer case studies and helpful videos and blog posts. You can use the Getting Started guide to create your first instance, read on how the role of the DB changes when you move to the managed databases, and how managed read replicas can help you solve your scaling and disaster recovery use cases. Or cut through the complexities of Oracle licensing with a blog post by our partner House of Brick. Thanks for spending this time with me, and have a nice day.